Distinguished guests, ladies and gentlemen, good afternoon. Welcome back to 2035 E-Mobility Taiwan Forum's Vision 2035. In the morning, we talk about different technologies subjects, including system integration, smart driving, connected technologies, and e-mobility trends. I hope that you have learned something in the morning. Besides the technical side, an application is also important in the e-mobility industry. People must be curious about future applications after listening to all these technology. Um, in the afternoon, we will talk about applications and future trends more. Now we switch to the next talk. Daniel Russ is the Director of Computer Science and AI Laboratories in MIT. She used innovative materials and 3D printing to enhance robotics understanding regarding with computing. Today, we are very happy to have Daniel Russ from MIT to talk about the talk with us today. And today, he will talk about the future of AI technologies in autonomous driving.
It is such an honor to speak to you today.
大家好，今
Today,
天
I
很
would
高
like to
兴能
reflect
够
on
跟大
where we
家
are
分
with the
享
state of the art in autonomy, especially in the context of self-driving cars. Advances in autonomy have the potential to make a big impact on transportation. For example, in a single year, Americans drive nearly 3 trillion miles. And if you average that out at 60 miles an hour, that adds up to almost 50 billion hours spent in the car. And the number grows exponentially when we consider the rest of the globe. That's a pretty big part of our lives we spend in cars. Now imagine, what if cars could learn? Learn how we drive, learn how to never be responsible for a collision, learn what we need when we drive. And what if they could become trusted partners that could help us navigate tricky roads, watch our backs when we're tired, and even make our time in the car fun? Your car could become your friend, and on your drive home, it could connect to your intelligent kitchen to get the items you're missing for the night and remind you to go to the supermarket to pick up cat food. Your car might also remind you that you have to do your pre-read for tomorrow's meeting and make it possible for you to get started on your way home by triggering a new type of autopilot. This is not the Tesla autopilot, which still requires the driver's full attention. Your car might even initiate chores at night, golem style. Well, this is the dream. An autonomous car capable of intelligent situation awareness for navigating any road situation. An autonomous car that will never be responsible for a collision and become the owner's friend. The dream is a ways away because there are core problems that need to be solved toward developing the science and engineering of autonomy. The dream goes back a long way. Do you know when was the first autonomous coast-to-coast drive in the United States? The year was 1995. The NAVLAT project from Carnegie Mellon traveled from Washington, D.C. to Los Angeles, California, and the car was in autonomous mode for a large part of the highway driving, with humans taking over at exits and in difficult situations. Now, remarkably, this was not the first time an autonomous car raced on public highways. In 1986, German engineer Ernst Dickmann started thinking about how to teach vehicles how to see. He bought a Mercedes van, installed it with computers, cameras, and sensors, and began running tests on an empty section of the yet-to-be-open Bavarian Autobahn. Now, in the early 1980s, computers needed up to 10 minutes to analyze an image. But to drive autonomously, a car needs to react to its surroundings. And to do that, the computers need to analyze at least 10 images per second. drawing inspiration from humans who are able to focus on what is important on the road only. The German team developed a solution to allow the robot car to see the streets. But all the tests required a test driver with a hands on the wheel ready to take over at all time. Visual processing improved from 1 frame per 10 minutes to 100 frames per second, and this has been game-changing for autonomous cars. The LiDAR sensors also decreased uncertainty and increased safety, and today we have many companies and research teams deploying self-driving cars. This is an example from our project in Singapore. The video was generated between 2010 and 2014. Now, our Singapore solution, along with a solution by many research groups and companies who are building autonomous vehicles, follows a recipe. The recipe starts with a platform capable of drive-by-wire. The platform is often a car converted to drive-by-wire capabilities. The platform is further extended with sensors, typically cameras and LiDARs, and a suite of software modules. The perception module provides support for making maps and for detecting static and dynamic obstacles. The estimation module provides localization information, and this is often based on features that can be extracted from the infrastructure. And the planning and control module computes how the vehicle should move, given input from the perception and estimation modules. Several key parameters emerge as we think about the range of the autonomy capabilities for these systems on wheels. How complex is the environment where the car moves? How complex are the interactions between the car and the environment? How complex is the reasoning, and how fast is the car going? And underlying these questions is a fundamental question: how does the car cope with uncertainties? Today, we have effective deployable solutions for robot cars that move safely in easy environments where there aren't many static nor moving obstacles, as you can see from this example, because the uncertainty is low and the vehicle has time to process the events. But sensors don't work well in weather, and the uncertainty of the perception system increases significantly if it rains hard or if it snows. The uncertainty of the vehicle prior increases as well in the case of extreme congestion and erratic driving, with vehicles, people, scooters, and even cows on the road, as you can see in this video I took during a taxi ride in Bangalore. Here come the cows on the right. There are many important preconditions, many of which revolve around uncertainty in perception, planning, learning, reasoning, and execution, before we can get to the goal of robotaxi. So today I would like to talk a bit about how to get self-driving vehicles to operate in more complex environments and how to enable them to coexist with human-driven cars. If we take a step back and look at the traditional AV pipeline, the key idea is to break up the problem and solve each subproblem individually, and there are many works that actually aim to tackle each submodule. In practice, this approach can be very difficult to follow, since it requires hand engineering of the parameters for each module and also for the connections between the modules. And specifying or hand engineering this kind of logic has been shown to be extremely brittle. We need autonomous systems to handle all types of road situations: nighttime driving, no lane markings, rainy weather. So instead, in our project, we aim to utilize large data sets to learn a representation of what humans did in similar situations. In other words, we wish to develop an end-to-end learning system that aims to optimize a single learning algorithm which directly takes us from raw sensory data all the way to control signals like steering, wheel angles, and acceleration. We can learn a model to go from raw perception, and here you can think of pixels from a camera, and noisy street view maps. These are not the high definition maps used by traditional autonomy solutions. So we use this input to directly infer a full continuous probability distribution over the space of all control. And here the red lines indicate the inferred trajectories of the vehicle projected out into the image frame, and the opacity represents the learned density function by our model. We do this by training a deep learning model to output the parameters of this conditional distribution directly from human driving data. It turns out that this model is capable of learning localization, point-to-point navigation, and also generalizing to new roads and even new intersections. And here's an example of successfully navigating through a roundabout, even though the model has never seen this roundabout nor any type of roundabout during training. We have extended this end-to-end learning how to steer from camera input to LiDAR input. And here the input is LiDAR coordinates and intensity and noisy location estimates. And the output is predictions into the future and evidential distributions to inform the model's uncertainty associated with its underlying predictive process. Our algorithm fuses deterministic predictions with evidential uncertainties in order to make uncertainty-aware control decisions, helping us combat sudden unexpected events that the model is not trained for, like the failure of a sensor. And I hope this example shows how understanding and improving the representation uncertainty leads to more stable and robust machine learning applications. Now, state-of-the-art end-to-end learning relies on collecting a gold standard of human driving datasets and then training a model to imitate what the human did. But even with ideal datasets, these models suffer when placed in slightly different states or scenarios from where the human drove. Collecting corner case data from near crash or crash scenarios is not feasible with human drivers. We developed a platform called Vista that enables autonomous agents to navigate anywhere within an entire simulated space around where the human drove and learn to drive without explicit human supervision. The idea is to collect one high-definition photorealistic drive that a human did, and then in simulation to modify that drive to represent corner cases such as erratic driving and near collisions. We built a brand new photorealistic simulation that leverages real-world driving data. And here you can see the power of the simulation engine. We collect one high-fidelity data set, and then in simulation, we are able to translate that data set into other types of driving, for example, erratic driving in this example. We are able to turn the policies learned in simulation directly into drivable policies. And here you see our vehicle, Toyota Prius, that is capable of autonomous driving, and that is using the policy learned in simulation to do point-to-point navigation in a new kind of environment. This vehicle was trained using urban data and is now able to take a first drive in a rural setting. A challenge with these end-to-end learning approaches is that the learned models tend to be huge black boxes, and there's no way for users to learn anything by examining the inner workings of the system. In this video, you see a rectangular box with blinking yellow, blue, and green lights. This is the reasoning engine of our end-to-end driving system. Below it, on the right, you see the map that the vehicle is driving in. In the top left corner, you see the camera input stream, and the bottom corner shows the attention map. This is where the reasoning engine looks to make decisions. The small rectangular boxes are the convolutional layers used to process the input stream. This deep neural network has over 100,000 nodes and 500,000 parameters. And in this network, each neuron or node is a very simple computation. The neuron computes essentially a thresholding function or a step function. Using inspiration from neuroscience, we have developed a new approach to learning representations we call neural circuit policies, or NCPs. And with NCPs, the end-to-end driving task requiring 100,000 plus simple neurons can be learned with 19 NCP neurons, and this results in a more efficient and interpretable system. And here you see the NCP reasoning engine on the right-hand side, and you can see each of the 19 neurons blinking. Therefore, you can associate the action of the neurons with the action of the vehicle on the map, thereby providing an explanation for how the neural network system works. Now, the neuroscience inspiration from the natural world is threefold. First, NCP neurons can compute more than a step function. Each NCP neuron is the liquid time differential equation, so much more powerful. Second, NCP neurons can be specialized, for example, to have sensory, inter, command, and motor neurons. And third, the wiring architecture has certain organism-specific structure. NCPs attend to the data in a much more focused way than other methods. And here we see that NCPs make decisions by looking at the horizon and the sides of the road, which is what humans do. Whereas the attention map for LSTMs, CTRNNs, and CNNs is much more noisy. NCPs and other compact representations are important for sustainability. Training and using machine learning consumes enormous amounts of energy. Researchers at UMass Amherst estimated that training a large deep learning model produces 626,000 pounds of carbon dioxide. This is equal to the lifetime emissions of 5 cars. These systems are so costly because each one contains hundreds of thousands of neurons and billions of interconnections. If we can develop simpler models, this can drastically reduce the carbon footprint of AI. Now, before I move to the next section, I would like to say a few words about driving in weather. Current AV solutions rely on optical sensors to make maps and detect lanes, and these solutions are challenged by inclement weather like rain or snow. MIT developed a ground-penetrating radar system called LGPR that achieves centimeter-level localization, and that could help driverless cars stay in lane when road markings are obscured. LGPR can also be used to make maps of the ground, which can then be used for navigation in place of a high-definition LiDAR-based map. Basically, the car looks down instead of looking up in order to localize and stay in lane. And we developed a solution for localization and following maps in inclement weather using LGPR. Here's the system in action. You can see the LGPR sensor behind the car, right here. So far, we have seen several examples of increasing the ability of robot cars to drive in more complex environments. Next, I would like to address how to get autonomous vehicles to be fully aware of the social contracts that people follow on roads. Human drivers and robot cars do not understand each other yet. Robot cars get confused when executing maneuvers that require that they understand if humans are yielding or not. Furthermore, they need to understand and respond to the rules of the road in order to behave in a socially compliant way. Now, specifically, robot cars have trouble deciding whether to speed up and go or slow down and wait for unprotected left turns. And we set out to model the behavior of other agents surrounding the ego car using one parameter from the social psychology literature called social value orientation. This parameter is an angle that measures the reward to self versus reward to others. For human-robot interaction, most relevant values correspond to prosocial, altruistic, or egoistic behavior. Here's how you can understand the SVO. Let's say you have to split $100 with a stranger. You can give everything away. This corresponds to altruistic behavior or an angle of 90 degrees. You can go 50-50. This corresponds to prosocial behavior or an angle of 45 degrees. Or you could keep everything, and this corresponds to egoistic behavior or an angle of 0 degrees. In order to have a better prior for the road situation, the ego car wanting to do an unprotected left turn measures the SVO to determine which control to adopt. Speed up and turn if the SVO of the incoming car is altruistic, or slow down and wait if it is egoistic. We have incorporated this idea into the control approach for autonomous driving, and our solution has 3 parts. First, we model the behavior of the surrounding traffic using social value orientation. Next, we establish a best response game where each agent maximizes its individual utility. And finally, we calibrate the rewards using real traffic data sets. For example, we use the NGSIM dataset. Here's the solution in action. The red car is an AV that speeds up and goes because the pink car is altruistic. In this case, the pink car is egoistic, and the red AV slows down and lets the pink car go before merging lanes. And now we have a pink car that's pro-social and slows down to make a gap and allow the red car to go. We are able to estimate the SVO online. Here you can see a simulation using NGSIM traffic. We control the purple and the green car using the SVO method, and we can see how these SVOs can be estimated in real time. It turns out that estimating the driver SVO improves trajectory prediction by 25%, and this translates to better traffic. Now, this is an extraordinary time for our field. There are so many opportunities for impact, for making the world better with robots. But technology permeates society successfully only if it is accompanied by supporting policies that define business and societal contracts. And in the case of self-driving cars, there are so many challenges. For instance, it is not legal to put self-driving cars on most roads on the planet today. We need to educate our leaders and our citizens about the impacts of our choices so we can make the right ones. And together we can build a common understanding around 5 vital questions. First, what can we do? Specifically, what is really possible? Second, what can't we do? Or specifically, what's not yet possible? For example, robot taxi is not yet possible. Third, what should we do? Fourth, what shouldn't we do? And finally, what must we do? Because I believe we have an obligation to consider how this technology can help people. We have talked about a number of self-driving capabilities, but what does this mean for the future of how people and goods get to their destinations? Well, in the future, increased autonomy will allow people to come together in intelligent offices, even if they are located at different locations, to collaborate seamlessly on the development of new technologies. For example, using gestures to develop new designs for flying cars. The new flying cars can be integrated with the IT infrastructure, and they know your needs, so they can tell you where you can buy the plants you've been wanting. Several companies are already working on flying cars. The simulation shows the concept of a flying car with thrusters that can enable vertical takeoff and landing. Just imagine a day in your life with no congestion because your car can take to the third dimension in the air whenever congestion is in its way. And so here is the simulation of the car lifting up. A system with cars that drive and fly will require complex automated management that can tell the vehicles where to go, how to cope with no-fly zones, and how to cope with no-drive zones. This requires optimization of when to fly and when to drive. And the research community is already beginning to think about these problems. There are many challenges along the way to developing the science and engineering of autonomy, and exciting opportunities to develop technical solutions to address those challenges. Algorithms that can handle uncertainty, reason symbolically, and offer real-time decision-making at scale will enable autonomy in more complex environments with challenging interactions. Today, we can have self-driving cars at safe, low speeds in low-complexity environments. In the future, we will see increased speed and complexity and mixed human-driven and robot-driven roads. But the future belongs to pervasive, self-driving flying cars and pervasive robotics. Along the way of developing these capabilities for robots, I believe we will also develop a greater understanding of autonomy, intelligence, and ultimately life. Thank you very much.
谢谢，我们非常感谢 Professor。
Thank you, Daniel Ross, for your presentation. I think that many people are excited about this presentation and the future. And now we'll move on to the next talk. Optimals provides CAE design for major auto companies in America, and now they focus on turnkey design. And this year, they will work with several local companies and regarding to developing autonomous drivings. And today, we are very happy to have representative from Optimal in Taiwan. We have Mr. Golden Yan to talk about global vision.
Thank you. I'm very honored and happy to be here as I'm invited by TAITRA to share with you how we are doing in Ultima in the United States. And also, if as we look at the traffic authority in the U.S., as they are promoting AV, and I would like to share with you the latest trends. After all, the market is not only in Taiwan, and of course, I would say U.S. possesses the biggest opportunity for my friends here in Taiwan. And the American market is really a big one, not only for cars, but also for automotive driving or related industries. So by this opportunity, I would like to share with you the latest trends, the situations of manless driving, and also the legal requirements. So actually, in 2017, the United States, the U.S. Department of Transportation has launched a automated vehicles comprehensive plan. They have this comprehensive plan based on preceding discussions. And it was in 2017, they proposed this subsidy plan as they demand the White House to sign and promote this. And actually now we are seeing 4.0 version for this automated vehicle comprehensive plan. So I'm showing you this slide because starting in 2017, the United States, they have been eagerly building up legal requirements, act plans, so that they can settle, they can create a safe but inspiring environment for the industry. So what does it mean by comprehensive plan? Actually, there are 4 directions. First of all, it builds on previous voluntary guidance. There were previous acts such as ADS 2.0, AV 3.0, and AV 4.0. So actually in USDOD, the U.S. Department of Transportation, you can see the details of these acts. And secondly, it explains departmental goals related to automated driving systems, ADS. It promotes collaboration and transparency and can modernize the regulatory environment as well as preparing the transportation system, because the legal foundation is very important for the development of manless driving and also electric vehicles. In United States of transportation, when it comes to the field of electric vehicle, buses, trucks, cars, are all very important. So starting in 2017, it has supported various plans. And from these plans, they receive the data which are used to revise ADS 3.0 and ADS 4.0. And at the same time, they were able to share this data, the real use case for this new technology. So this is the whole picture. The vision is 4.0. Intending to inspire how users can be prepared for future transportation system. And in the United States, they look at the safety of the vehicle and people, and of course, cybersecurity. Once you have automated driving, the information will be pushed out. And at the same time, that means you will receive information from other cars. So if you have a hacker, of course, there will be a big leak. So that's why related authorities, they are having a lot of discussions, and actually this is one key highlight for them. And if you look at the primary goals, conduct appropriate safety oversight of ADS. And for the United States, when they are supporting these plans, they would pass these notices to public authority or private authority. It would be a formal announcement. After all, this technology is not mature yet, so we still need a lot of data to be shared and examined. So here we see, for example, we see stakeholders monitor and identify the problems, issues, and needs. And also for those who are willing to dedicate themselves in EV, the government can provide guidance to industry to encourage transparency and adoption of best practices. Last but not least, it can facilitate information sharing, because manless driving, there's a lot of technology, new technology, just like what MIT shared just now. At the moment, AV 4.0, it has aligned 38 federal government, along with some independent committee and foundation. And the President Office a lot of public authorities, it has been promoting autonomous driving, especially in the Biden administration, because it's not just about the cars. You need to have the IT infrastructure. Everything's important. And Also, for goal 2, modernizing the regulatory environment, meaning that we need to eliminate the unnecessary obstacles and accidents in relation to the innovative car design. So there are multiple ways, including streaming paths to deployment, updating existing regulations to remove unnecessary barriers. And goal 3 is preparing the transportation system, meaning all researches and experiments, we need to make sure the safety and also delivery of this research. So that's targeting ADAS 4.0. Actually, next slide, including the state government or federal government, they are dedicated in these plans. And of course, we need to update infrastructure standards to reflect ADS technologies. So lots of people, actually in Taiwan, we're already doing this, including camera, infrastructure, ADAS safety, and also we have V2X. Actually, these are the advantages. I mean, these are what we are good at. So if you want to get more data in the United States, of course, you need to have a partner in the US, and then you can have a demonstration, and it will receive subsidy from the state government and also federal government. And now they're doing a lot of AV tests. And in my next slide, I will show you in traffic, the smart traffic, the state government will subsidize these experiments, encouraging innovation. And actually here in the red square, since in Taiwan we have the products ready, and if we can have, we can work with our partner in the US, and we conduct demonstration to gather more shared information. And I think there will be a big leap and actually a faster way to push our local prowess to the global arena. And Taiwan is also an ideal spot for autonomous driving tests. In the United States, geographically speaking, it's bigger, it's less crowded. However, in Taiwan, because we have mixed routes, we have cars, we have motorcycles, it's more complicated. However, in Southeastern Asia, it's more complicated, I mean, compared to Taiwan. For Taiwanese component makers, if you want to enter the autonomous driving field, you can first locate a partner in the United States, and then you can get a subsidy and you can learn from local technology. And once it's verified in Taiwanese market, and then you copy this model, duplicate this model to the Southeastern Asia countries, there will be a safer route. So here in the United States, we have more than 13 states, including Arizona. They are having test run in different locations. We can say the United States, they are very active promoting these technologies. So when they are testing AV, different traffic status are categorized. For example, street, not specified, or highway, these are popular testing sites. So you can see here, when they are doing AV tests, passenger cars, the most common cars, they have 54 cases, and for shuttle bus, they have 53 cases. So if you look at this slide, personally in Ultima, we work with the 3 top car makers in the United States. We help them in the design of passenger car. However, if we want to compete with electronic cars, we really cannot compete against the top 8 car makers because they have all these rich resources compensated by the government, etc. So Optima, we need to identify a niche resources. So we move to shuttle bus. In the United States, actually in the business cars, they have class 1 all the way to class 8. In Taiwan, we have most common class 6 size. So we target this medium shuttle bus category. If we can be successful here, of course, it's a very good vehicle, a very good medium to verify your concept. After all, if the bus is too small, no, I'm not targeting anyone here. It's just, for example, you only have 5 to 6 passengers, and you need a capacity of 20, and a 12-meter car. Actually, it caters to 5 to 30 people. So for mass communication, you need to have a minimum of passengers. And in the United States, it's categorized as passenger bus. So at the age of autonomous driving, this is something that contains more business value. After all, they have a minimum of number of passengers. In the United States, now they are testing with airport buses, and it always starts with 20 people a bus. So these are some revision in the United States. And of course, in the United States, they ask for safety for cars and also for people. The regulations are clear. So if you want to penetrate the American market, first of all, you need to follow the SAE legal requirements and standards, meaning that including software, ADAS, safety concerns, they have related regulations. So you must refer to that. That's what we call standards. And in the United States, now we have 4 key categories in subsidy. Number 1 is a low-speed truck. It's no faster than 25 mph, and because it's only carrying goods, so it wouldn't be too much of a problem. And also for passenger vehicle, it launches a conditional driving automation. There's a speed limit, only 40 kilometers per hour. These cars are not yet allowed on the highway. And for passenger vehicle automated driving system, they are limited as well. And for automated trucking operation, actually in the United States, they collaborated with Logistics Association to initiate a project of automated port. And on the other hand, other opportunities for business operation would be low-speed passenger shuttle. The low-speed passenger shuttle SAE level is 4, and the speed is 40 kilometers per hour. In the United States, the speed limit will be 70 miles per hour. So that's almost more than 100 kilometers an hour. But it can have it can increase incrementally. So in Taiwan, we have low speed, and in the United States, they focus on they want to help the elderly and also the physically challenged. So that makes a difference. And of course, like AIT mentioned, this is the latest proposal and policy. by Biden administration. First, sensing, and then perception, planning, and control. I think it's been explained pretty much by IIT, our friends from IIT. Actually, in Taiwan, we are doing sensing, and the camera makers and also other manufacturers are not LiDAR. And all these parts, I think the key is really planning. And that means you can rely on people who have experience in designing cars, because the ideas, the learning ICT is very different from what we learn in a car making factory. So I think the biggest difference is here, because the experiences are completely different. When you are designing a car, there are different logics. For example, when my car is driven here, I stop here. Do I turn left or turn right? There are different options, different methods. But when we are designing ADAS, we have one key that is, in Taiwan, we focus on brand. Okay, when you see a risk, okay, you take preventive actions. Okay, that's brainy reaction. But your car, if you want it to be as precise as you are, and make a judgment whether you should turn left or turn right. Actually, in Taiwan, we are still missing talent in this segment of the action, because we do not have experiences in designing a car or integrating resources. This is my personal opinion, and this is not I'm not criticizing, but if you have ever, worked in the United States, they are really strict and discreet in car designing, but in Taiwan, that's completely a different scenario.
经验。
This is another program called SPAT in America. We have a 5G alliance in Taiwan. They can use this one as a reference. So this is for your reference. It's a big opportunity. So in the United States, 26 states are committed, and there are 216 signals operating and more than 2,000 signals planned. I can show you a video. This is in Michigan State. And of course, Detroit is one of the major auto capital in the States. They have a Avenue program. I can show you the video. It's about autonomous driving concept. Later on, you will also get to see Department of Transportation's ideas in the video as well.
Our future is trending toward autonomy, and the transition has begun. This really is not a matter of if, but rather a matter of when. CAVNU, the public-private collaboration project that is taking a drastically different approach. Who is driving this approach? Alphabet, Google's parent company and world leader in technology. Welcome to the Connected and Automated Vehicle Corridor concept. Interstate highway system defined mobility in the second half of the 20th century. Now, transportation in America and around the world is changing again. Mobility in the 21st century will be defined by intelligent, connected, and autonomous vehicles. CAVNU is designing the physical, digital, coordination, and operational infrastructure to accelerate and realize the full potential of connected and autonomous vehicles. The goal? To make roads safer, shared, less congested, and sustainable. CAVNU will draw on an advisory committee of automotive and autonomous mobility companies, including Ford, GM, Argo AI, Arrival, BMW, Honda, Toyota, Too Simple, and Waymo to develop OEM neutral standards. CAVNU's approach is centered around creating a digital model of a roadway that analyzes and optimizes road conditions in real time, shares information, and provides proactive guidance to vehicles and drivers. There are 4 key use cases. 1. The future of public transit. In dedicated CAV or connected autonomous vehicle lanes, they aim to offer transit solutions that are smarter, safer, and more efficient. 2. The future of freight. Autonomous trucks can benefit from more constrained environments to achieve greater speeds, more safety, and to operate in less congested areas. This addresses challenges at key choke points such as ports, congested highways, tunnels, bridges, all of which will optimize the movement of freight, an increasingly crucial part of our economy. 3. The future of personal transportation. Autonomous vehicles operating in these lanes can use the information from their surroundings to communicate with each other to move faster, safer, and at closer distances, allowing more capacity in the same space. And 4. Supporting conventional vehicles. In addition to dedicated lanes, CAVNU will equip roads that can accommodate mixed traffic with technology and infrastructure that improves road safety and congestion. This includes improved traffic management, predictive maintenance, safety alerts, and advanced tolling solutions. CAVNU is developing a first-of-its-kind connected corridor in Michigan, the birthplace of the automobile and the home of 75% of U.S. automotive R&D investment. Over the next 2 years, it will explore the viability of a 40-mile connected corridor. In the first phase of the project, CAVNU is undertaking a feasibility analysis to inform the development of a first-of-its-kind connected corridor in southeast Michigan, connecting downtown Detroit and Ann Arbor.
Imagine a future where vehicles talk to one another and to critical infrastructure. This connected vehicle technology can change our transportation system as we know it by enabling safe, interoperable, networked wireless communications among vehicles, infrastructure, and personal communications devices. Connected vehicles provide drivers with 360-degree awareness of similarly equipped vehicles within a range of approximately 300 meters. This secure system keeps personal information private and does not track your vehicle. Drivers will receive warnings that inform them of potential hazards through a visual display, seat vibration, or tone. Warnings can help drivers respond quickly to avoid potential crashes. For example, the Intersection Movement Assist application warns drivers when it is unsafe to enter an intersection. Connected vehicles can help with weather-related traffic and safety issues too. This is especially true with conditions such as black ice, where the weather may not appear to be dangerous, but the roads are slippery. Information collected from multiple connected vehicles can help determine when a potential hazard exists, such as icy roads, and warn drivers before they experience them. Connected vehicle technology can help pedestrians too. For example, the Mobile Accessible Pedestrian Signal System app sends an automated pedestrian call from the smartphone of a pedestrian with disabilities to the traffic controller, holding the walk signal until the pedestrian has cleared the crosswalk. This application also alerts drivers of the presence of a pedestrian with disabilities at the crosswalk. The potential benefits of a connected transportation system, one that is able to enhance safety and mobility and address environmental impacts, are wide-ranging. They will be felt by every one of us, enhancing the livability of our communities and ultimately making our transportation safer and smarter. Imagine the possibilities.
因为时间有限哈，就是我在那讲的重点就是。
So due to time constraint, the point I'm saying is that Ultimo is already joining this consortium. We're involved in this car renew. So due to time constraints, originally I have a video to talk about smart transportation and mobility. If you're interested, I can show you later in private next time. We hope we can find ADAS suppliers in Taiwan to work with us, so we can verify these technologies in the United States and deployed to major automakers. Thank you. Thank you for your presentations. Please take your seat. Now we move on to the next talk. Kingway Tech is committed to mapping, and it offers maps to Google and automakers around the world. Through AI models and big data analysis, they analyze billions of historical data of traffic informations. So it's one of the few certified service providers by international car makers. Today, we are very happy to have General Manager Sam Huang to talk about future lives with smart mobility technology. Good afternoon, everyone. I am Sam from Kingway Tech. Today, we'll talk about future lives with smart mobility. And we provide smart transportation solutions. At the beginning, let's talk about the motivations to reform and revolutionize mobility, because we encounter three different issues here. The first one is environmental pollution. In 2015, we had the Paris Protocol. We hope that we can have carbon neutral environments by 2050. So many corporate owners have been talking about carbon trade as well as ESG issues. This is something that we have to deal with around the world. Also, we are seeing in the urban environments, there are many environmental pollutions. There are increasing numbers of mega cities, many population inflow into urban environment. But due to COVID-19's pandemic, we are seeing that people are now sprawling out to suburbs again. But still, the overall situation is still the same. That's with growing populations around the world, so we are seeing more pollutions in urban environments. Since the pollution comes from these vehicles, traffic safety is another major issue as well. And according to statistics, that out of the 1.3 million traffic accidents around the world, 94% are man-made. That is partly related to aging populations. As baby boomers retire and ages, we are seeing increasing numbers of traffic accidents. And so that means that the traffic safety issue is critical and paramount to the human society. And there are also about mobility issues. As we see more vehicles and more cars in the city, another issue is traffic congestions. With or without traffic accidents, congestions is a serious issue in many cities, and they have to deal with in many different ways. When I take a look at traffic information, so all the cities are actually in rush hours. They're all congested. It's happening not just in Taipei, Beijing, or all the other major megacities around the world. And so in rush hours, actually there are no meanings to doing traffic control because it's all congested. So if we do not deal with traffic congestions effectively, and for example, in the United States in 2019, they estimate that they will lose 88 billion NT dollars because of congestions a year. So the reason why we are reforming mobility is because of pollution, safety, and congestions. When the city is congested, you will consume more power and you will generate more pollutions. These are all interconnected issues that we have to deal with. So in order to respond and solve these issues, we have to reform our mobility. So mobility technologies have to become part of the solutions. In recent years, we divided the smart mobility into 4 aspects. You can see 4 of them here. The first one is connected. So all the vehicles are connected, and they are connected to traffic signals as well. And this is the fundamental infrastructure. Without doing this, you are not going to proceed. So it is related to infrastructure. With connected infrastructures, we can talk about share service. As we said before, there are more and more cars around the world, but in many vehicles, there are only one driver or like one driver plus one passengers. So the occupancy is not ideal either in the cities. So in many cases, 50% of resources are wasted. So people have been talking about shared services in order to reduce the number of vehicles, and our spaces are limited in these cities. We do have to think it in the reverse way. How do we reduce the numbers of vehicles required during the mobility process? And we can talk about autonomous as well, and it's related to big data and smart vehicles as well. And if you have autonomous vehicles, then you don't need that many drivers anymore, and that can also respond to manpower shortage issue we have in Taiwan and around the world. I don't know if you're aware of it. Japan is an aging society. In Japan, bus drivers and taxi drivers are more than 60 years old on average.
Many of these drivers, even though they're in their 60s, they still have to drive taxis, to drive buses, so that the society can stay mobile. However, at this age, actually, it's, you can say, exhausting, also not as safe to have a driver in his 60s. So we need more applications or tools to ensure safe driving. And speaking about electrification, of course, it's a kind of digitization. So now that most industries have experienced digitization, electrification is not as difficult. And it's also related to pollution. After all, in urban areas, if we can reduce pollution due to emission, of course, it will have better life quality. But by switching to electricity, that means we are switching pollution to other places. For example, the remoted power plant with all the pollution in remote areas. However, in the process of fuel-based power production or other green energy, actually, it's 24 hours. Let me put it this way. For the power plant, it's day and night. Actually, the electricity cannot be stored. So that's exactly why sometimes we see all the street lamps stay lighted all day, not only all night. So if we can reduce the emission in downtown, it's still helpful to reduce pollution overall. And those power generated in remote plants, if you can store, for example, in our container or the energy power storage in the bus, we are stopping the waste. And then in peak hours, we save more power. and we are reducing the overall power consumption. I mean, when you have power switch to electricity and save in electric cars, actually it's helping saving the waste of additional power. The smart mobility is changing the interaction among people and cars. As you can see, cars are not just your car. You are not necessarily the owner of the vehicle. And in this system, most cars are public cars or sharing cars. More and more vehicles are part of public transportation. It could be passenger car or transportation system. We are getting closer to sharing system and carpool, and the relationship between people and cars will be redefined, and cars will no longer be part of transportation. Like I said, electric cars, we can help save energy, we can help save power from power generation. Electric cars is not just about transportation, it's also part of energy supply life cycle. And this is something we've been discussing in the new green energy scene. In the future, not just the future, actually, it's happening now. If you look at the personal lifestyle arena, as we are so used to e-bike, I think the victims will be the bike makers because they are selling less bikes. However, users are shifting their preference to, for example, mountain bikes. And we are so used to walking in the city. Not everyone would ride a bike. And we are seeing more and more cars, they are released to public use. It's no longer just being owned by a user. And for example, we have less number in designated taxi pool. I mean, we can release a greater number of cars to be used in multiple ways. And also we have multiple transition from A to B. Have you heard about an app called 转乘通 that's actually made by my company, by King Wei? Actually, it was launched in 2015. It's a tool first ever available in Taiwan because we combine information of transition combination, but it's no longer available in the App Store because we have sold this app to Google and Apple. So if you are using your Google app, Map, or Android app, actually it's our product. So we can reduce the use of personal vehicle. And for mobile payment, actually in Taiwan, local governments are promoting QR code and also Line Pay. In the future, it will be getting increasingly easier to consolidate the paying process in every aspect of life. In general lifestyle, if we look into the last mile, connected living, so to speak, as we can see, nowadays, we are seeing increasing volume of traffic, so people are asking for on-demand transportation. That is when the user has a demand to travel, and only then they would ask for a vehicle to take them to, for example, from A to B. That way, we make transportation more efficient. And also, for traffic lights, in order to support the fast development and also to improve the efficiency of public transportation, and also offering more options for consumers, we have designated traffic lights for public transportation. Just a few months ago in Kaohsiung, we tested a new services that allows buses to go through the street faster. And once we accelerate the cycle or the movement of the cars, of course, we improve the efficiency, we decrease carbon emission, and all this contribute to the sustainable city. And eventually, man, car, and the city, we can have a sustainable growth and coexistence. And now I would like to introduce to you what we have done in Kingway in smart mobility. Kingway started with eMap, including Google Map, FO Map. In Taiwan, it's actually provided by Kingway. And our first achievement is in high precision mapping. Not only we provide the product to Taiwan government, but also NVIDIA, and also in Japan, they need private driving map. They are also using our product. In Taiwan, in addition to map-based GPS, we have auto-connected services. For example, if you drive Toyota, the back office is in Kingway, and also BMW and Audi. As long as the cars are connected to internet, this auto-connectivity are using our products in Kingway. And in the past few years, we are dedicated in the commercial application, and we look into the different product mix, and we aim to build solution from the commercial cars development. And here we have 6 self-driving cars in Taiwan. 5 of them are shuttle buses, and 1 is a street cleaning car. And we have 3 plans and commercial scenarios. We are one team that is willing to embrace innovation. I would like to introduce to you the first site is in Xinbei-shi, the New Taipei City. And this is a place where they have the longest history and the most experiences in Taiwan for self-driving tests. And we allow the driver from Danshui Keyun, even though they are really experienced driver, but they can still launch, turn it on and off, allowing the managed buses to finish the cycle. And for Qinggui, and we have 1.2 kilometers for testing sites. And the second site is in Taoyuan area. We are guiding the people and also from the passengers from released from the airport once they get on the shuttle bus, and you can key in the plate number of your own car. And actually, this is on-demand services, but the bus can take you to where you need to be, and this is all automated. And site number 3 is in exclusive industrial park. So in Hutousan, this is also a 5G testing site. We always start with a closed industrial park testing site and then expand the small project to external communities. And number 4 will be Qingpu. We are using the manless street cleaning car so that we can reduce the incident of human cleaning team. We can reduce the incidence of car accident. And number 5 is in Zhanghua. And in Taichung, Meinong, we are also planning additional sites. And all these different sites, they have different characteristics. the reason why I explain this is because they bring different insights to us because we are still innovating, experimenting. So we need new challenges, different challenges, so that we can learn different skills. Last but not least, I would like to add that manless cars, well, it's not something to be accomplished in the short term. I mean, you can, if you really want to imagine, okay, all the streets is filled with manless cars, there will be like 20s, 40s, or 50s, and by the time we are too old. However, this is level 5, level 4. This is in the development of manless cars. But level 2, the driver assisting department, the driver assisting system, I think is under development, and we are seeing a lot of experiments and results from this field. So we have solutions to ensure the driving safety, and we have all this sensory components to support the trucks, especially big logistic vehicles, to improve the efficiency. And we have our own demo. I mean, right here at the first floor, we have our booth. Feel free to visit us right here in this building. So our solution is designated for bigger cars, the buses, and also street cleaning cars. And they are available right here in this building in our booth. So feel free to visit us. Thank you for your sharing. And last but not the least, starting in 2017, Microsoft has been deploying cloud solutions for manless cars, for focusing on cybersecurity and cloud services. And now, in collaboration with Cruise, leveraging the Azure cloud computing platform, the capabilities of the managed cars are improved. It's our honor to have Catherine from Microsoft Taiwan. Let's welcome her. Kathy Yet, Principal PM Group Manager, Industry Clouds and Solution at Microsoft. Her topic is vertical integrations enable smart IoV applications.
Good afternoon. I am the last talk before the panel discussions. I just listened to King Wei's presentations. I think it's a great talk. Today I have a very broad topic. It's about software-defined vehicles for development. Today we focus on two concepts. When Microsoft talk about Internet of Vehicles, and some people may be curious about our motivation. I've been in Microsoft for 18 years. I was doing Windows marketing in the past. At that time, many people were PC users. Our impressions to Microsoft was mostly about new Microsoft Windows versions, and as we know that people are switch and buy new iPhones or their smartphones every 1 or 2 years. When I start to work on Internet of Vehicles, my parents asked me if I was very interested in cars. I think our approach is not about making new PC or new Windows. I think now Microsoft is a service provider. When we look at the new business model, we are not focusing on upgrading or buying new products. We want to produce a more sustainable environment and ecosystem. So today we'll give you the Microsoft approach. In the automobile area, we are not automaker. We work with automakers around the world. like tier 1 OEM or tier 2 OEM. I also work with a lot of service providers such as Kingway. We also work with manufacturers. So on Microsoft, we have cloud service, we have AI service, and all the IoT platforms. We help them to do car designs and car manufacturings, including ADAS as well. And we utilize big data to train the models. We also develop mobility services such as energy and management, battery management, and fleet management. As we are not a car maker, we are not competing with them. We build partnership with them. Several speakers have mentioned about electric vehicles, and many cars are digitized now. Digital vehicles will generate a lot of data. The reason why we may have autonomous driving in the future is because of inputs from sensors and cameras. And how do you utilize all this data? That's why data processing and data storage become very important. So OEM partners and manufacturers want to utilize this data. Later on, I can show you an example. I will not go into the autonomous driving technologies because other speakers have talked about it already. On an IOV platforms, there are all kinds of innovations and applications that will evolve over time. Maybe in 10 years or 20 years, we will get to level 3 or level 5. But now when we think about battery management or power management, it also evolves over time. It is growing very fast, so we cannot think about this in the traditional way. It's no longer a lengthy and time-consuming environment. We have to use a more agile environment and technology to develop all these upcoming applications. This morning we have speakers from MIH, consortiums, and other partners. What we want to enable is a cloud-native open EV platform. Some people may think this graph is complicated, but actually you can see there are 4 major directions. There are many components, battery modules, or control modules. And we need to manage, control, and monitor all these modules. They may need real-time response. They may be business criticals, but they need faster developments and deployments. So if you want to have a cloud-native open EV platforms, when you have so many computing powers in the vehicle, how do we deploy it in a more flexible way so they can be allocated and utilized more freely? So this is a new structures and architecture that we are building now. So in the cloud, there are all kinds of possibilities. We are now working with partners on a growth marketplace. So for Internet of Vehicles or for all the services, there will be a marketplace. You can develop softwares for the vehicle or for backends or for personal devices. You will have a open developments and open environments for DevOps, which is deployment, developments and operation. Let me show you an example.
好，那我们就来谈 V2G 哈，刚好正好接着刚刚。
This is a V2G solution. With electric vehicles, you need to have charging stations. Of course, you need to install their mobile applications and you need to know where the stations are. So every car, there is a major and large-scale battery, and you can have the battery capacity. So it is possible that you can actually deliver your batteries and your power back into the grid in certain scenarios. So we have a solution with MIH here downstairs, so you can take a look later. So this is a two-way street now, not just charging from the grid, but you can also send in power back to the grid. So for the charging stations, you need operation and maintenance. For each stations, you have different charging poles, and you can have storage equipment on site as well. You need mobile applications, and they'll connect it to the battery management system. There may be different specifications for the charging stations. Whether you can support them is another story. So just a charging solutions requires different components and elements. And there are different applications as well. It's easy now to offer on-site demonstrations. But for a platform like this, we envision it to be deployed around the world in different cities, and we also need to support international standards as well as the individual's requirements. That's why we need to have an open platform. First of all, in the BMS, in the battery management systems, you need to monitor the battery life cycle. And some people ask about whether constant chargings or frequent chargings will influence the health of batteries. So you need to have an optimized battery life cycle management. That's something that service providers and manufacturers cares a lot about. So we need to monitor all the systems regarding to chargings and dischargings process. Today, when we are doing energy management systems, Taipower is involved as well. Taipower is the national power company in Taiwan. When we have more and more electric vehicles, and some people are concerned about power supply. We think that electric vehicles can become an opportunity for the power supply in Taiwan. If you can enable the power sold back from the electric vehicles to the electric grid, then they can become an asset to the power system. not just in liability. So your life cycles management is important. Your battery management is important as well. So that's why we are building this energy management system with MIH and other partners. This is from the Thai Power Company. Last year, and they are having these install capacity. So the renewable energies include solar power and wind power, hydropower, etc., etc. In the future, we are seeing increasing numbers of electric vehicles, and the electricity capacities within EVs can reach 9%. It's a huge number. So we hope that electric vehicles can balance the grid and also provide stability in the grid system. So we hope that through the system they can anticipate and predict demands and supply. For example, you may need 5 megawatts per day. If you anticipate or predict there are only 3 megawatts of power needs the next day, then they can reduce the power generations or they can modify the power generations. Currently, charging stations are providing backup facilities, but we can change the common situation now. This is another slide coming from Thai Power. For power supply, their demand estimation is the -1. So currently the system is not very easy to operate, but we hope that in the future it can be very flexible. So currently the Thai Powers will announce and publish the demands in the next day, in the next 24 hours. And that's based on what their estimates. And so for power plants in other facilities, they can utilize the power transaction platforms to see what are the opportunities. For example, you may see a power gap from 2 to 4 in the afternoons, and you can either modify your demands or you can sell your power back to Thai Power and the electric grid. And this is what we are trying to do with the charging stations or the battery or power management systems in the future. So it's a coordination effort. This is what we try to do in Taiwan. Due to different regulations and infrastructure differences around the world, there may be other flexibilities and other real-time response to the power gap.
So this is, as you can see in our booth downstairs, this is a V2G scenario that is auxiliary market for a day before electricity supply. So we are supporting this project, this solution with storage facilities. For example, you can have a device, you can have an interface to check how much electricity you would need for the next day and how much is available at Thai Power. So on the one hand, Thai Power can check how much electricity is available. And if it's not enough, for example, it can call back the electric cars back, and then the cars can release more electricity. And later, I will share with you a short clips of on how it works. For example, the drivers, they can use an app, and the app will push notice whether the car will be needed, or actually they can sell the power back through the recharge pole. And the pole with the electricity stored can make a decision whether it's going to transmit the power back to Taiwan Power, earning some price gaps. So what does it mean really to recharge the car? Because at low hours instead of peak hours, at that time when you are charging the car, you spend less money. The cost is lower. So this is a V2G scenario. With this idea, we can stabilize power supply. Here are screenshots from our demo. We work with ES Energy. So ES Energy leverages a portal. For example, they have data from Taiwan Power so that they can have a forecast of how much power is needed at when. And they would know somehow at which time slots they are still missing power. And they are managing a lot of charging poles. So they can access the data in each pole, and they will have a more precise estimate of how much power can be recalled and how much can be sold back to Taiwan Power. For example, 4 to 6 p.m. it could be a peak hour, and there might be a shortage of electricity, for example. And in this slide, as you can see, we are working with ES Energy. They trust this back office to Azure. It's our marketplace. So in Taiwan, and maybe in other places, if you need V2G electricity supply, you can use Marketplace to test, and you can download or deploy the solution. On the other hand, we have mobile apps, and due to time constraints, I'll stop here. And if you're interested in how to operate these mobile apps, feel free to visit us at MIH booth. You can see a real demo there. Last but not least, I would like to share with you car internet or automobile connected internet is a big topic. It's not about making more cars, but it's about development of softwares. And in Microsoft, we have worked with partners for V2G, and here I'm very happy. Again, I'm very happy to be here to share with you. For Vision 2035, the birth of smart mobility not only changed the history of car making industry, it also created a brand new lifestyle from EV and also limitless cars, the research, the development, also manufacturing. All these different journeys have disrupted the industry, and all this technology are rewriting our lifestyles. And coming up, the next segment is our panel discussion for the afternoon. Now let's look at the video.
定会赶上。
Peter， 不好意思打扰你的假期。
没事，我先把可能问题传给你，你先帮我准备一下。
我这边都准备好了，等你到了之后，我们就可以直接开始。
And the manufacturing threshold is no longer its advantage. And transformation will have to start with technology so that the ultimate goal will be delivered, and it's an achievement relying on AI, big data, and its accumulated effort of all kinds of technology. In Taiwan, as we have a lot of startups in technology, how can we collaborate with one another for collective achievement? So now let's welcome our speakers from the afternoon session for panel discussion. Now I would like to call our distinguished guests. Let's welcome Mr. Golden Yan, Director of Vehicle Design and Development in Taiwan Optimal Company, Kathy Ye, Principal PM Group Manager, Industry Clouds and Solutions at Microsoft, Sen Huang, General Manager of Kingwei Tech Technology, Jerry Wang, Automotive Research and Testing Center President, and also Mr. David Shen, CEO of Turing Drive. Now let's have a group photo. Feel free to take photos. Thank you. Thank you for your time and also the photo. And now it's time for you, John Wan, Editor-in-Chief, Business Next. Thank you, dear host. Good afternoon, everyone, distinguished guests on the stage, in the audience, also online. I'm very honored to attend this 2035 E-Mobility Taiwan Forum. My name is Zhang Wang. I'm Editor-in-Chief, Business Next. And actually, in the afternoon session, we had 4 speeches on the trend of manless driving. And I think the trends have been shifting. And I remember in 1999, it was my first time visiting MIT. And at that time, they had computer science lab, and I remember the other is automobile, and it's Benedicturo and Gunilla Ross. He is now the leader of an integrated lab. I mean, the 2 labs I saw in 1999 now have become one. And in these fields, whether it's in retail, finance, or manufacturing, the AI is again a big supporter for future trends. And in the afternoon, these different speeches, including Professor Ross, saying that in the future, we can see not only smart cars, but also the flying cars could be one possibility. So in the future, not only cars, but also drones, if they are combined together, there will be a new start for logistics. Now let's get back to the ground. We have 3 experts who just had presentation, and then we have 2 additional experts joining the panel discussion. So my question is, since this topic is about smart mobility, so with the vision of 2035 in Taiwan in smart driving, what are the possibilities and opportunities in Taiwan? Maybe my question will start with Jerry. Jerry Wang, Automotive Research and Testing Center President. Maybe you can share with us what are the opportunities of Taiwan in manless driving.
Hello, I'm Jerry Wang from Automotive Research and Testing Center. They're also 14 years away from 2035. And many developers are now focusing on level 2 or level 3 of semi-autonomous driving. In the next 15 years or so, I believe there will be a huge progress. For example, on the bus side, you will see a autonomous driving bus fleet becomes a part of public transportation. They will be able to replace some of the MRT systems in different areas. I think commercial vehicles is another opportunity for cargo truck and on highway. It will save a lot of driver manpower and energy consumption. For personal vehicle, we will able to see level 3 to level 4 autonomous driving. They will find their available parking lots by itself, and there will be fewer people purchasing cars in the future. They will have autonomous driving systems in the future and an autonomous driving fleet in the future. In Taiwan, we have a lot of manufacturers who can produce these components like mapping, positionings, and sensors, for example. Due to the trade frictions between China and America, I think that in Japan and Korea, they have their own automakers, and so many Americans automakers will approach Taiwanese companies. I think that we can supply some components and electric system as well. So in the next decades or so, that we will able to see the electric systems from Taiwan being sold to different parts of the world, and we'll focus on electric autonomous bus and also commercial vehicles and some level 3 or level 4 private vehicles. Last year, our revenues for the car industry is 260 billion NT dollars. I think that in the near future, it will be double to 500 billion NT dollars. So it is a very appealing and promising numbers, as we are seeing major companies are moving in, and some startups are moving as well. So next, I would like to ask a startup perspective. How about David Shen's from Turing Drive? Hello, I am David Shen from Turing Drive in Taiwan. Before we answer these questions, I think we need to ask ourselves, what are the issues we have to deal with ourselves when we have autonomous driving vehicles in Taiwan, and what kind of roles we can play around the world? If autonomous driving vehicles from Tesla or Google coming into Taiwan, what kind of preparation we have to do? And we know that they will need to have very high definition mappings, and in that situations we need local suppliers to provide localized informations. We have our own traffic features as well. We have scooters, for example, in Taiwan. That is not an issue that Europeans or American automakers focus a lot on. So we have to rely on ourselves to deal with the scooter issues. And with these experiences, we can apply these technologies and these solutions to other countries with scooters, such as Southeast Asia. We also need a smart infrastructure in order to facilitate and accelerate autonomous vehicles deployment. In the global supply chain, what kind of roles can we play? Just as what Mr. Wong has said, we can work a lot on the auto electrics. So in the future, we need to combine all the components into a system, and that will create another opportunity. And MIH is another promising development, and we are very optimistic about MIH and its developments, as we are switching from fuel power cars to electric vehicles. You can see the entry barriers for vehicle manufacturing is getting a bit lower. So you are seeing more emerging startup car makers. In the past 10 years in China, for example, we see a lot of new car companies and new car manufacturers in China, Southeast Asia, or Europe. For us in Taiwan, we can be a very innovative ODM. We can offer a lot of additional values to these components. You can provide a very comprehensive turnkey solutions. I think this ODM model is something that industries in Taiwan are familiar with. I think this is an opportunity that we can take advantage of, and that's what I think. I want to refer the same questions to Golden's and Sand. In your presentations, you talk about shuttle bus, especially those slow-moving shuttle bus, as an opportunity for us. And Optimal mentions the American example. Do you think the same rules and same prospect apply to Taiwan as well? Do you think that we should approach those shuttle bus? Of course, private vehicle is a huge market, but it's still a bit far away from us. Do you think that in the short term, we should focus on shuttle bus? I can talk about it from an operation demands now. I think for public transportations, we need a lot of vehicles and public transportations in remote areas or in rural areas. We see driver shortage, and they cannot reach the scale of economy. So it is difficult for them to maintain public transportations for mountainous area or remote areas. The government has provided some solutions for share service. A few years ago, we saw an advertisement from Japan that a bus travel in the rural areas that carry senior citizens to urban areas for shopping or health check. So Japan is taking a very aggressive steps in order to respond to the aging situations and power and the human driver shortage. So I think that we also need to pay attention to this. While this technology is novel, we have to use these novel technologies to resolve a lot of practical issues. So we are moving from control and slow-moving scenarios, moving to a more complex and high-speed scenarios. So in a control environment, we need to accumulate our technologies. We need to start with enclosed environments to designated areas, and then to accumulate those experiences in order to power our development ahead. So for example, these shuttle bus for rural areas and tourist destinations are urgently required in the near future in Taiwan. That's why we have these pilot sites in different areas in Taiwan. We have this pilot site in remote area in New Taipei City or in Changhua coastal areas. This technology actually operates very smoothly in a controlled environment. Therefore, that we need to respond to the practical challenges we have in Taiwan regarding driver shortage, aging society, and also scale of economy. So I think that this is something that we should approach first in the near future in Taiwan. I think this is an interesting point, and if you think about priority, we should probably prioritize rural areas over urban areas. As you can see that in the rural areas, we do not have sufficient drivers, and it is not any very economic solutions in the past to have regular buses. So that's a very interesting approach. How about you, Mr. Golden Yan? I think that with government support and actual needs, it's more likely to succeed in Taiwan. For example, if you want to operate a rural bus route in Taiwan, it's not cost effective. It's very expensive. It's not even profitable. So I think autonomous driving bus are feasible in Taiwan, in rural area, and its development will be much faster. And I think it's more likely to happen. So it will bridge several issues, for example, the digital gap, but also the needs in the rural areas. So the next question is referred to Gordon and Kathy. We talk about priorities in Taiwan. We focus on slow-moving vehicles in rural areas. And of course that we are also developing and researching on autonomous driving technologies. So what are the potential business model in the future? For example, Gordon had mentioned about Cruise under GM. They are building their business models. So what do you think about the business model in the future for autonomous driving cars? In America, they are searching for different business models as well. Department of Transportation in America, they talk about consumer transportations and cargo transportation as well. So there are different levels. In America, they do need a lot of truck drivers, and they have to drive over long distance, and they have to cross different states. So they hope that they can replace all these truck fleets with autonomous driving trucks. Actually, Mr. Huang have mentioned about it. They're trying to reduce costs and reduce collisions, and it is now under development. I know that several state governments in United States, for example, Canada, California, Texas, Connecticut, and Texas, they are working on this. I think Florida and Connecticut are using public transportations as AV test. And they are also building their infrastructure at the same time. So these state governments in America are committed to these developments. So I think the commercial feasibility for public transportation will move faster. So at least the American governments are trying to do this. So the same question will be referred to Kathy as well. We mentioned about Cruise under GM. So Microsoft and Walmart are also investing in this field. And Microsoft is also participating in this field. How do you think about this? We decided to work with GM and Walmart to invest in Cruise. We have three major objectives. The first is zero crash. You can avoid collision. That's an important goal for the autonomous driving cars, is to avoid traffic accidents. We also want to reach zero congestions. We can have a better traffic flows without congestions and without waste in energy. The third objective is zero carbon. Microsoft is a technology enabler. We provide machine learning and big data platform. We are providing these technologies to accelerate technology developments because it requires a lot of computing powers to train all the models you may have. So our approach is not just about passenger car. I think we want to do more. We want to ensure sustainability. It's related to energy management. Since Walmart is investing in this brand as well, so it will be related to smart city, logistics, and fleet management. Of course, this development and investment is accelerating this industry. So we want to join the market and to become one of the players. Cruise was a subsidiary under GM, and now they have more new investors. As we are seeing, the automotive market is changing, and Microsoft have been working with major car makers over the years. You're also seeing a lot of emergence alliance. For example, Benz and Mercedes are working together. Companies like Porsche are also building up STD platform. In the futures, you may see more car companies or automakers spin off their service and into an independent service providers. So in IOV area, they are shifting from traditional car manufacturing to service. These are some of our observations that I can share with you. So as Microsoft and GM work together, it also symbolized that ICT companies are working with traditional car makers. We do have some mature ICT developers in Taiwan, so that can become another opportunity. So Microsoft is now offering a lot of service through the Azure platforms, and you have to provide a lot of connected, real-time, and low latency services. So cloud service and cloud platform become very important. And Azure has been a very general platforms in the past. Last week, we are seeing that Microsoft is working with hospital as well for the cloud services. So many cloud service providers are also breaking into a lot of industry verticals. So how do you support this? Because in the past, Microsoft is not familiar with car or automotive industry. So how do you work with them through the Azure platforms? In the past, people thought about Microsoft as operating system. So we have been working with Ford, for example, in the infotainment system in Ford, but you don't see it in the first place. So we were the underlying operating systems in many cars. So Microsoft is now launching an industry cloud and highlights several verticals. For example, connected car. We have a platform called Azure Mobility. So for infotainment, for ADAS, for monitor system within vehicles are all included in the Azure Mobility platforms. There are also healthcare clouds or manufacturing cloud as well. After we provided all these cloud services, we acknowledge that we need to work together with industry players. It is not impossible to build it by ourselves. They have to work with business leaders in order to know what is needed and what is moving on in these industries. Because of COVID and the trade friction between China and America, people are realizing all these technologies are changing and moving even faster. So therefore, in the past few years, we are seeing more opportunities and more collaborations between different verticals. For example, we are moving into automotive industries and also logistic industries. So in the process, you will see new opportunities, but you will also encounter new challenges. Thank you, Kathy, and you represent the cloud service provider. My next question is referred to David and Sam. When we are driving cars, we need to make decisions in a quick second. And in that situation, you need a lot of edge computing capabilities. While you are driving on the road, you need to take priority. You need to recognize. You have to give way to police cars or ambulance as well. So these computing systems need to understand the road conditions, traffic conditions. You need to identify and recognize all the players on the road. So you need to rely both on clouds and edge. So I want to know that what is the latest developments in edge computing, and also from the navigation perspective, how is it developing now? I think now we have been talking about infrastructure. First of all, cars need to be connected in order to distribute information and receiving information. I think in Taiwan, only 20% of cars are connected now, but the number is growing and the percentages are growing. So if you consider or include your mobile devices into the calculations, then maybe 50% of our cars are connected. But I think that after our cars are connected, then we need a very centralized system as well to monitor and manage the whole traffic systems. For example, this centralized system can send warnings to individual vehicles, or they can manage the traffic system, the traffic light system as well. And this is what we are seeing in the past few years. So besides connected cars, we also need connected signal systems. Just like what I mentioned in the presentations, we need to have these two things ready before we can have autonomous driving vehicles. It will be an evolutionary process. You need to think about communications between all different vehicles and communications between vehicles and traffic signal systems. So there are a lot of prerequisites before we can see autonomous driving vehicles available on the road. In comparison, if you think about logistics or rural areas, it's a more controlled environment because they have fixed routes. It's easier to monitor and manage the traffic signals on these fixed routes. And for example, you can give priority to ambulance or police cars. It's an easier way to deploy. Even for autonomous driving bus, you can also deploy in the same fashion. And I think the ITS Association have been promoting this kind of developments, and we are actually working a lot on the smart city developments, and we can also export this kind of model to Southeast Asia as well. I think for autonomous driving, we also need to think about the whole smart city system. So smart city are related to the smart transportations, and that's something we can explore in the future. And of course, this autonomous driving is not just about individual vehicles. You need to have computing power. You need to communicate with the traffic signal systems. You also need to connect everything together in order to demonstrate the powers of autonomous driving. I know in Taiwan, the traffic situation is very complex, and think that we have the highest scooter penetration rate among the developed countries around the world. And you don't see that many scooters in other developed countries or other countries with higher incomes. So the user scenarios in Taiwan will be very different from those in the United States. For example, our situations may be more similar to Southeast Asia. So from your perspective, what are the other things that we need to have before we have the whole system?
To answer your question, well, actually, before that, may I borrow a few minutes from you? I would like to share with you some different perspectives because I do not have the background of electronics or computing. Actually, before I joined this company, I was in smart logistics, smart traffic. So as I look into this issue, actually, I might have different perspective. I would take the perspective from a overall transportation ecosystem. When I was studying in college, from the first page, we talk about traffic jams. It's like in all products because there's no storage. I mean, for example, you're going to have a long weekend, and traffic is, you can imagine, it's a kind of product that cannot be stored. So the flexibility on the road cannot be stored in advance in preparation for a long weekend to come. So is it possible that we minimize the gap or the traffic jam with autonomous driving? For example, when smartphone arrived, the traditional feature phones went through an industrial disruption. And with smartphone, we have a completely new way of communication with text messages and social media, etc. And autonomous cars, it has seamless communication among one another by leveraging different materials. In the future, as we have these in-car sensors collecting information of where are the traffic blocks or traffic issues, does it mean all the information data level are equal in every car, as if they share the same program, that all cars can make the best decision based on optimized data? I think that would be the ultimate value that an autonomous car can bring to overall traffic. I think by the end of this topic, smart car will be like a smartphone. Gradually, there will be a platform, and it will be of public value. In the past, if all the car makers work in silo, that they do not communicate or collaborate with one another, then it will be really a long way till we can see cars communicate with one another. It's not just among cars, but also among cars and people, and also cars and other devices. So more and more people are talking about this infrastructure or the communication protocols of B2B, B2C. I think in the future, the factor to determine whether autonomous car can be popular, this could be one determining factor. Let me share with you some examples. Nowadays, autonomous cars is not yet popular. Reasons why, as we've been hearing the delays of all this implementation dates. For example, Google, in the very beginning, they say, okay, autonomous car would arrive by 2019, and you see it's already 2021, and now we're seeing a new date of 2035, as you can see on the poster. From my observation, when there are autonomous cars and men driving cars, then the autonomous cars would be not easy. I mean, it will be a long way for the autonomous car to be implemented because people, the drivers, the human drivers, are the most risky factors in this system. As long as there are still human drivers, I think the autonomous car wouldn't arrive as soon. So a lot of big companies, Waymo, the stakeholders in the industry, they've been saying that, for example, Waymo in Phoenix in Arizona, they've been saying that in that big metropolitan area, because they have less people, so the autonomous cars can be running around. And Toyota is also trying to prove that when the system can be completely managed, computing, without human drivers, and actually it's doable. And the reasons why autonomous cars have to be this smart is because we are imagining all the ultimate scenarios or the crazy ideas. Whatever could happen on the road with human drivers. So maybe when we do not have human drivers, then smart cars can become dumber. So when is the time that autonomous cars can be implemented? Maybe that's when human drivers can leave their seats. Well, actually, in a lot of inventories, the manless robotics, they are moving the cargoes. But for autonomous cars, when they are on the roads or highways, when they are in the carpool, for example, they are driving along with other cars. My question to Gordon may be in this scenario, for example, ADAS, like you mentioned. One part is ADS and ADAS. One comes with advanced, and one is automated, the other is advanced. And automated means there's no need to have a human driver in front of the wheels to drive the car, whereas ADAS, the advanced driver support system, it's to support the human driver. So these two technologies, maybe my question would be, in the future, all these autonomous cars, is it possible that we don't need a human driver? What's the difference between ADS and ADAS? Well, in SAE, in ADAS, we have level 1 all the way to level 5. And under level 4, the cars are driven by human. And at level 4, the cars are not driven by men. And in the United States, like I said, if we could have this opportunity to have a U.S. partner, whether for investments or joint venture, actually, you can learn a lot there, because in the United States, what they're discussing now, it's in the legal and also ethical perspectives of autonomous car development. From David, I listened to what he said. Well, the way to AV, actually, my boss, he said 3 years ago, he said 2035. But now, at current stage, if you look at current progress in the United States, I would say an optimistic date will be 2041. However, I would like to clarify an idea. To deliver autonomous driving, there's a prerequisite. All systems need to be driven by wire, meaning it should be electrified. However, now that the cars, especially electric cars, are not as popular, even though we have Lucy and Tesla, those are actually passenger cars. Electric cars, well, electric vehicles, of course, that include buses. Maybe we can set a goal for research there. However, it would be better to develop step by step that we electrify the cars first, and stage by stage, and then driven by wire will be possible, and then in AV. And now that I think we are restricted in this aspect of research because people are doubting whether it's commercializable. And if you look at the industry step by step, maybe we can start with the related industries. We should lay solid foundation for related industries. And then we can study more. We can have more exposure to overseas market. After all, the products are to be sold. We made this product for revenues, right? My next question will be for Mr. Wang. Jerry Wang, Automotive Research and Testing Center President. I think now a big part of this automated system is the key technology we need. So to complete this puzzle, I mean, what is your perspective? If you look at the car makers or startups, do they need to work more with academic circle so that they can have the picture complete? Well, this topic is related to what Gordon just said. We did not talk much about hardware linking software. Maybe like Gordon said, it's control on wire. When the car is moving forward, brake or back or turn, it must be controlled by wire. That means you need to have a software controlling all these actions. However, in the very beginning of this panel, let's say if our infrastructure, 5G, cloud computing, everything, if it's getting mature, it doesn't mean, I mean, by that time, it doesn't mean a highly capable CPU is needed for every car. I mean, with a mature infrastructure, you can rely on ROSA units or auto AIoT to determine the status or the situation. So, like we said, like Gordon mentioned, the algorithms computed in the car, if we have the infrastructure as complete as everything on the road is controlled by the sensor from traffic lights to the signs, then, for example, I can write algorithm, I can have program control, but I have little knowledge of the suspension system or the brake system. I only know about coding, but I know nothing about the car. Then I wouldn't be able to write a program. Well, ICT is good at writing program or coding. So lots of times I get questions like, okay, we have good capability in ICT. We can design smartphones. We can produce a lot of mobile devices. How come we cannot switch quick enough to car use chip? Well, like you said, collaboration with colleges or research institutes. Well, when it comes to the traffic situation, how do we determine what's happening on the road? For a car, especially a manless car, the decision is about whether it should stop right away or turn left or wait for how long. And in school, they have the expertise in software. So, of course, talent comes from school. And if we have enough talent supporting the car electronics and also autonomous driving, I think all the information can be consolidated. And like I said, it's not just about cars. When it comes to IT and smart transportation, and today actually our topic is smart ecosystem. It's not just about cars. It's like integrating the smartphones and also the signs on the road and also 5G connection and cloud computing. If we have powerful cloud computing, then we don't need CPU for each car. And they don't have to be very smart to move forward if we have a mature environment in 5G and cloud computing. So today we are thinking, okay, maybe we are too slow, but don't haste. Haste will make waste. Let's say now that our autonomous car at 30 kilometers per hour, 50 kilometers per hour, okay, it's safe. But let's say if we have 80 kilometers per hour or even 100 kilometers per hour, team of trucks and they are only 1 or 2 meters apart, they will need a lot of computing power. And also, like we mentioned, if we have motorcycle on the road and also maybe a dog or a cat all of a sudden dash into the middle of the road, there might be some harm. So there are a lot of challenges and also possibility of incidents on the road. So of course, in challenges, there are opportunities. And in Taiwan, we are so good at smartphone, panel, and also hardware. There are lots of opportunities. But I have to emphasize that it's not just about hardware. We have to focus on software. So last but not least, my question is to Kathy. In Microsoft, you have cloud computing services available in Microsoft. Also, you have CPG. You are investing some startups. Also, you have accelerators. You're supporting a lot of startup teams. So how do you look at development of smart driving in Taiwan? Do you see any potential groups that they are doing well? And these startups, for example, from Microsoft perspective, whether you can recommend them to accelerator or you can have closer partnership? Yes, of course. I've been supporting some local accelerators and also the startups in Taiwan. And the fellow panelists have mentioned and discussed a lot of, for example, smart buses, B2B, B2G. Actually, I've been harboring this question. What do you mean by opportunity? And is it opportunity for better life for everyone or is for the industrial sector? If it's just about improving the lifestyle and life quality of everyone, of course, there are a lot of opportunities. But if you narrow down to the industrial factor, I would say the power of startups. I mean, it would be a great energy injection to the traditional shown power. I mean, for those long-lasting stakeholders in the industry, they need startup to refresh their eyes. In the past, the manufacturing industry, they talk about millions, right? That's millions of costs. So they look at the volume of the production. However, when we are discussing service, we talk about the business value and business model. For example, recently there's one startup. They came to me. It's not about autonomous car. It's about blockchain. A few days ago, I was in another meeting. It's about carbon neutralization, carbon emissions. So maybe you'll need blockchain technology to release traceability. So maybe we need a refreshed view, not from the traditional manufacturing perspective, but really we need a refreshing view. Maybe we start with the demand. How are we going to accommodate the new needs? And from Microsoft's point of view, when we look at this startup proposal, their solutions, we look at whether it's possible that these ideas, these solutions can be shared around the world. So we look at the services perspective and also markets perspective. It's not just about technology. So
today, our panelists have talked about this issue from different perspectives and different approaches. I think the real autonomous driving will happen probably after 2050, but there are a lot of services and designs that we can start to think about. We should start from the low-hanging fruits, and we can talk about long-term prospects, but it's always an evolution that we have to take several steps in order to reach that ultimate goal, and it will not happen overnight. We need to accumulate experiences and technologies over time, and there are also some external factors such as legal. Please give them a round of applause. Thank you, everyone, for your participation. This concludes our forum today on 2035 E-Mobility Taiwan Forum. We would like to thank everyone's online and offline for your participations, and we hope that you can fill out the surveys to us so we can improve on the events in the future. After completing the survey, you will be able to receive a presentation by our guest speakers today.